Good morning, pre-calc. Hope you guys are having a good day. So today we're going to continue on with some more of our matrix work. In our previous lesson, we learned about the determinant and how we can find it. And now we're going to go ahead and see how we can use that determinant to actually solve systems of equations. So first off, we have to learn how to write a coefficient matrix. So given a linear system, so something like this right here, which we're used to seeing from our lesson a couple weeks ago, the coefficient matrix that goes along with it is just -1, sorry, not -1, +1, -5, and -7, 2. See how I just took the coefficients from my variables there? Yeah. So we actually have this system we can use in order to solve systems of equations called Cramer's rule. Okay, so it's named after this guy, a Swiss mathematician, and he basically takes the coefficient matrix and determinants to solve a system of linear equations. So this is what Cramer's rule actually is. Okay, so given a system ax plus by equals z and cx plus dy equals f, and we let A be matrix A be A, B, C, D, which is that coefficient matrix we were just doing. Okay? As long as the determinant of A does not equal 0, then the system has a unique solution given by x equaling the determinant of EBFD over the determinant of A, and y equaling the determinant of AECF over the determinant of A. So, if the determinant of the coefficient matrix equals 0, then the system does not have a unique solution. So that's this guy right here that we were just saying, that determinant of A cannot equal 0. That means it either has no solution or an infinite number of solutions. So let's go ahead and try and use Cramer's rule. The first thing I'm going to do, here's example 1 we're looking at. I'm going to go ahead and I'm going to come up with my coefficient matrix. We're on that A, right? So that's going to be 1, -5, and -7, 2, right? So figuring out the determinant of A is pretty easy. It's just going to be 1 times 2 is 2, minus my -7 times -5 is 35. It looks like we get -33 as the determinant of A. And then we can go ahead and we can set up our formulas for x and y. So I'm going to start off with x. So you got to pay attention to these letters. So we're basically going to be looking at this guy up here, ax plus by equals z and cx plus dy equals f. And we're going to be using those guys. So this first one is EBFD. Okay, so E is going to be 9 in our problem here. Okay, and then B is going to be -5. F is going to go ahead and be -30. It's a negative there. And D is going to be 2. And that whole thing is going to go over our -33, which was the determinant of A, right? So what we have to do is we have to figure out this determinant, which is going to be 9 times 2, which is 18, right? Minus 30 times 5, so that's going to be 18 minus -150, 30 times 5 over -33. Right? That is, oh sorry, you know what, that should be a positive 150, right? Because they're both negative. I missed that negative on the 30. And then that's going to give us something like 132, -132 over -33, which reduces down to 4. So our x value for this guy is 4. And then we're going to do the same thing for y. So remember, you got to pay attention to this situation here. And it's going to be, our A value is 1. And we have E, that's 9. And C is going to be -7. And F is -30. Yep. And that's all going to go over that -33 as well, the determinant of A. So to figure out the determinant of this guy up here, that's going to be 1 times negative 30 is negative 30. Negative 7 times 9 is going to be negative 63. And when we add these guys together, we get positive 33 over negative 33, which is negative 1. So it looks like our answer to this guy would be 4 comma negative 1. And although it looks a lot different, essentially what we're doing is we're just figuring out where these two equations would intersect on a graph. It's just a different way of doing that. So let's go ahead and do one more with two equations, and then we'll go ahead and check out some 3-variable systems. So for this guy, start off with your coefficient matrix, which is going to be 2, 6, 5, 1, right? And I can find the determinant of A pretty easily. It's going to be 2 minus 30, right? Which is negative 28. So there's our determinant of A, which we'll be using a few times here. And then for X, we're going to go ahead and remember, look back up at your formula. Okay, so the matrix we're going to be dealing with here is EBFD. So that's going to be E is 38, right? And then B is going to be 6. We have F is negative 3, and D is 1. That's all going to go over negative 28. So then go ahead and find this guy. That's going to be 38 minus negative 18 over negative 28. That gives you 56 over negative 28. Looks like our X value is negative 2. And then we can go ahead and continue on and find our Y value by doing a similar deal. In this case, we're going to do A, E, C, F. Remember, we're looking back up at these guys here. Okay, so that's going to be something like 2, and then E is 38, and then C is 5, and F is negative 3, all over our determinant of A. Okay, so that's going to be negative 6 minus 5 times 38 is, let's see, I think that's 190, right? All over negative 28. So that's negative 196 over negative 28. And when we divide those, you should get 7. So our answer for this guy is negative 2 comma 7. Okay, so the cool thing about Cramer's rule is that we can actually expand it all the way to 3-variable systems. And in this case, what I'm going to do is there's a link that in the announcement that I made for today's lesson that takes you to a little calculator that can calculate the determinant. And that's just because it'd be pretty tough to go ahead and do the determinant by hand for all these guys because we're doing a bunch of them. So we still have to pay attention. As you can see, we have a bunch of different letters that represent the different coefficients and whatnot. Okay? So we got to pay attention to how we find our X, our Y, and our Z. But like I just said, go ahead and use that link in the announcement to figure out the determinant of each of these guys. Right? So the first thing we're going to do is we're going to find the determinant of A, our coefficient matrix. So that coefficient matrix is going to look something like this right here. It's going to be negative 1, 7, negative 2, 2, 1, 9, and then 3. That looks like a negative 3, but it's not. Okay, that's just 3, negative 5, and 2. Okay, so remember in the past, in our last lesson, we learned we can find this by hand, but I want you to just use that website, and the determinant of this matrix is going to be 140. Okay, so determinant of A is 140. So that's what we're going to put at the bottom of each of our little formulas here. So first, let's figure out X. Okay, so really got to pay attention to how these guys are all set up. This one's JBC, KEF, LHI. Okay, so remember we're just gonna kind of look at the example up here and then pull from this guy where they match. So I think we're gonna do -14, it looks like. And then we're doing B and C, that's 7, -2. And the next line is gonna be KEF. So that's KEF, that's 43, 1, and 9. And then the last line is gonna be LHI, so it's LHI. And you kind of see like a little bit of a pattern, 2, -5, and 2. So go ahead and in your calculator, on that website I shared with you, go ahead and find the determinant of that guy. Remember, I don't want you doing these ones by hand just for the sake of time. And it should give you something like -700. And we get an x value of -5. Yep. And then we're going to do the same thing for y. Right? So once again, this guy's over 140 because that's the determinant of A. And let's take a look at this. We got AJC. So AJC, that's going to be -1, -14, and -2. Next one is DKF. DKF is 243, 9. And then we got GLI, that's going to be, GLI is 3, 2, and 2. Yep. And once again, go to the website, figure out the determinant of this guy, and you should get -140 for that determinant. And we get -1 as our y value. And then we still got to do z. Remember, in 3 variable systems, we're going to have 3 answers here. Right? And for this guy, we have ABJ. Okay, that's going to be -1, 7, and then -14. DEK. Okay, that's going to be something like 2, 1, 43. And then we have GHL. And remember, I keep referencing this guy. GHL tells me it's going to be 3, -5, and 2. Right. Figure out the determinant using your website, and you should get 840 over 140, which is 6. So our answer is going to be -5, -1, comma 6. Nice. So definitely a little bit different of a process than what we did to find out answers to 3 variable systems a week or 2 ago. Okay, but a cool little way that we can still solve these systems, but by using matrices instead of elimination. So let's go ahead and practice this a little bit by doing, let's just give you 1 through 4 on homework 8. 1 through 4 on homework 8. That just gives you one of the 3 variable systems there. Okay? You also have a quiz in the classworks tab. Hope you guys have a great day.